The Ford 351 Windsor has a distributor hold-down bolt. It is a single bolt. It costs nothing to loosen. When you slide a $2 steel washer under the base of that distributor and rotate the housing 3 degrees clockwise, the engine knock that has been rattling your bearings stops, not reduced, stopped. Mechanics on fleet lines from Detroit to Dallas used this fix for 50 years straight. Then electronic engine management arrived, everyone forgot it existed, and now people are paying $8,000 for engine rebuilds on problems that a hardware store part would have prevented. That is the entire story. Today, we are walking you through exactly how to do it, when it works, when it does not, and what to check first before you touch anything. Before you go near the distributor, you need to know what kind of knock you actually have. Not all engine knock is the same, and this fix addresses one specific type. Get in the truck. Start it cold. Let it idle for 2 minutes. Now drive it and listen. If the knock appears under acceleration, you press the gas. The engine loads up and you hear a sharp metallic ping or rattle. That is detonation knock. That is what this fix is built for. If the knock is present at idle, constant, deep, and rhythmic, that is rod knock or bearing knock. That is a mechanical failure. No washer fixes that. That is a tear down. Know the difference before you waste a Saturday. Detonation. Knock happens when the fuel in the combustion chamber ignites before the piston reaches top dead center. The spark fires too early, the fuel burns at the wrong moment, and the pressure wave inside the cylinder slams against the piston that is still moving upward. That pressure spike is what you hear. It sounds like someone dropped a handful of marbles inside your engine block. Under light cruise, it might be faint. Under hard acceleration, pulling a grade, it will rattle loud enough to make your stomach drop. Left alone, it holds pistons. It cracks ringlands. It hammers rod bearings. The repair starts at $2,000 and climbs to $8,000 fast. The cause in most cases on a mechanical distributor engine is timing that has drifted too far advanced. Here is where most people stop and take it to a shop. Do not do that yet. On every carbureted or points ignition engine built before 1996, the ignition timing is controlled by a distributor. Examples include Ford 302, Ford 351 Windsor, Chevy 350, Chrysler 318 and 360 LA engines, every Ford F-150 from 1983 through 1996, and every Chevy C and K truck through 1995. The distributor sits on top of the engine. It has a housing that rotates, and the base of that housing is held to the intake manifold with a single bolt. That single bolt is your entry point. When timing drifts advanced on these engines, and it does especially after 100,000 miles of heat cycling, worn centrifugal advance weights, or a vacuum diaphragm that has started to leak, the spark fires too early. The engine knocks, and the fix is to retard the timing. Move the spark event back a degree or 2 or 3. The washer shim is how you do it without specialized equipment, without a shop visit, and for $2 in parts. Here is what you need before you start. You will need one SAE number 10 fender washer, a flat washer, with a thickness between 10 and 30 thousandths of an inch. Aim for the thinner end, 10 to 15 thousandths of an inch. One standard fender washer from a hardware store or auto parts counter costs between 50 cents and $2. Get 2 so you have a spare. One SAE number 10 fender washer, flat style thickness, 10 to 30 thousandths of an inch, preferably 10 to 15 thousandths of an inch. 2 washers total, 1 spare. A socket wrench and the correct socket for your distributor hold-down bolt, typically 1/2 inch. A torque wrench if you have one. A timing light if you have one for verification. The basic fix can be done without it. Step 1. Let the engine cool completely if you have been driving. You will be working near the intake manifold and the distributor. Hot aluminum can burn skin. Give it 30 minutes minimum. Step 2. Open the hood and locate the distributor. On a Ford 351 Windsor, it sits at the rear center of the intake valley, driven off the camshaft. On a Chevy 350, it sits at the rear of the engine block between the valve covers. On Chrysler LA engines, it is at the rear driver's side. The cap is round with spark plug wires radiating off it like spokes, and the hold-down bracket clamps it at the base. Step 3. Pull the distributor cap. 2 spring clips, or 2 screws, usually hold it. Set the cap aside without disconnecting the plug wires. You only need access to the base. Step 4. Take a paint marker or a silver paint pen and mark the current position of the distributor housing relative to the intake manifold. Draw a line across both. This is your baseline. If you ever need to go back, you know exactly where you started. Step 5. Locate the hold-down bolt. It goes through a bracket that clamps around the base of the distributor. Loosen it, do not remove it, just loosen. 2 or 3 turns is enough. The distributor housing should now be free to rotate slightly. Step 6. Slide your SAE number 10 fender washer under the hold-down bracket between the bracket and the intake manifold surface. This raises the bracket slightly. When you tighten the bolt back down with the washer in place, the distributor housing will rotate clockwise, which is the retard direction, by approximately 1 to 3 degrees, depending on washer thickness. Step 7. Rotate the distributor housing clockwise by hand toward the firewall on most applications, approximately 2 degrees. 2 degrees is a safe starting point. You are not guessing wildly. 2 degrees of retard buys you margin without costing significant power. Step 8. Snug the hold-down bolt. Do not torque it fully yet. You want it tight enough to hold, but loose enough that you can adjust if needed. 25 foot-pounds is full torque. Start at 15 foot-pounds. Step 9. Reinstall the distributor cap. Reconnect everything. Step 10. Start the engine. Let it idle for 60 seconds. Listen, then take it out and drive it hard. Get on a highway on-ramp or find a grade and accelerate from 30 to 60 miles per hour under load. That is the exact condition that triggered the knock before. If the knock is gone or significantly reduced, you are done. Torque the hold-down bolt to 25 foot-pounds and call it. If the knock is reduced but still present, go back in. Add a second washer of the same thickness under the bracket. That gives you another degree or 2 of retard. Drive it again. Most detonation knock on these engines resolves completely within 2 to 4 degrees of retard from the base position. Here is where most people fail. They over-retard. They keep stacking washers because the knock is gone and more retard feels like more safety margin. It is not. Excessive retard robs power, kills fuel economy, and can overheat the engine by burning fuel too late in the cycle. 2 washers maximum. If 2 washers of standard thickness do not stop the knock, the timing is not the only problem. Now here is the reality check on this fix. It works on engines where timing drift is the primary cause of knock. On a well-maintained engine that has developed knock after a fuel quality change, you accidentally ran regular 87 in an engine that wants premium, or you got a bad tank with high ethanol content, the washer shim is your fastest path to silence. On an engine that has been sitting, running lean from a failing carburetor, or has heavy carbon deposit buildup in the combustion chamber, the washer helps, but you will need to address those underlying issues. Carbon deposits are a separate problem worth understanding. When combustion chamber carbon builds up over 80,000 to 150,000 miles, it raises the effective compression ratio. Higher compression ratio means higher peak cylinder pressure. Higher peak cylinder pressure means the fuel detonates more easily. The timing fix helps. But if your spark plugs come out black and crusty with thick carbon deposits, you also need to run a can of Chevron Techron concentrate or BG44K through a full tank of premium fuel. Techron runs about $20 at any auto parts store. BG44K runs about $22. One treatment through a full tank addresses combustion chamber. carbon buildup on engines that have not had a deposit cleaning in years. Do the timing fix first, do the fuel treatment second. Those two steps together solve the problem on the vast majority of pre-1996 distributor-equipped engines. Spark plugs are the third variable. If your plugs are original equipment past 60,000 miles, or if someone installed the wrong heat range, too hot for your compression ratio, the plug tip itself becomes a glow point inside the combustion chamber. It superheats and triggers pre-ignition before the spark even fires. Pull your plugs. Look at the tip. The insulator should be light tan to gray. Black and sooty means a rich mixture or carbon fouling. White and chalky means it ran lean and hot. If any plug looks wrong, replace the full set. For a Ford 351 Windsor or a Chevy 350, a full set of NGK Power or Denso copper plugs in the correct heat range runs between $20 and $35. Install them correctly gapped to manufacturer spec. 44 thousandths is the standard starting point on most of these engines, and they are a legitimate part of the knock solution. Here is what this fix does not address. If you have rod knock, a deep rhythmic knock at idle that speeds up with RPM, present at startup and constant, a washer and a timing adjustment will not help. Rod knock means a connecting rod bearing has spun, worn through, or lost oil pressure. You can sometimes confirm rod knock by pulling spark plugs one at a time with the engine running and grounding each wire. If the knock changes or disappears when you kill one cylinder, the rod bearing on that cylinder is the culprit. That engine needs to come down. The repair cost starts at $2,000 for a single rod bearing replacement and climbs to $5,000 or more for a full bottom end rebuild if bearing material has contaminated the oil passages. The other thing this fix does not address is the vacuum diaphragm. The distributor on these engines has a small vacuum canister on the side connected to a port on the carburetor or intake manifold. That canister advances timing under light load for fuel economy and retards it under heavy load to prevent knock. When the diaphragm inside that canister develops a leak, and on engines past 100,000 miles it often has, it throws the advance curve completely off. Disconnect the vacuum line going to the canister. Cap it with a golf tee or a vacuum cap from the parts store. Drive the truck. If the knock behavior changes significantly, the diaphragm is compromised. A replacement distributor vacuum advance canister for a Ford or Chevy application runs between $8 and $15 at any parts counter and is a direct bolt-on replacement. That $8 part plus the $2 washer is your complete toolkit for timing-related knock on a pre-OBD2 engine. If you want to do this correctly and verify the results, borrow or buy an inductive timing light. They run between $20 and $40 at Harbor Freight for a basic model. With the engine idling, the timing light connected to the number 1 cylinder spark plug wire, and the timing marks on the harmonic balancer visible, you can read your actual base timing against the specification stamped on the emission sticker under your hood. Most Ford 351 Windsor engines from the mid-80s want 10 degrees before top dead center at idle with the vacuum advance disconnected. Most Chevy 350 engines of the same era want 8 to 10 degrees. If you are reading 14 or 16 degrees at idle, that is too advanced. The washer fix that moved you back 2 to 3 degrees just bought your engine several 100,000 additional miles. The total cost of this repair on a pre-OBD2 truck is as follows. One SAE number 10 fender washer costs $2. A set of replacement spark plugs costs $25 to $35. One can of Techron fuel system cleaner costs about $20. An $8 vacuum advance canister if yours is leaking. That is a total of approximately $55 to $65 in parts if you do everything. Your labor is approximately 2 hours on a weekend morning. The alternative, ignoring knock until it holds a piston, starts at $2,000 and runs to $8,000 for a full rebuild. That ratio is 40-to-1. You spend $50 or $60 now, or $8,000 later. This fix works on every mechanical distributor engine ever built. Ford 302, Ford 351 Windsor, Ford 250 inline 6, Chevy 250 inline 6, Chevy 305, Chevy 350, Pontiac 400, Oldsmobile 455, Chrysler 318, Chrysler 360, all of them. Same bolt, same washer, same 2-degree clockwise rotation. Mechanics used this on fleet trucks, farm trucks, and work vehicles for 50 years because it worked every single time. The problem was timing. If you own a truck with a distributor and you have any knock at all under acceleration, this is the first thing you do before you spend a single dollar at a parts counter or shop. Loosen the bolt, slide the washer, rotate 2 degrees, torque it back, and drive it hard. The knock stops, or it does not. If it does, you just saved yourself anywhere from $200 in shop labor to $8,000 in engine work. If it does not fully stop, you have 2 more variables to check: the vacuum advance canister and the spark plugs, before you move to any deeper diagnosis. That is the complete process. The complete timing specification chart, washer thickness guide, and spark plug heat range reference for every pre-OBD 2 distributor engine covered today is compiled in the field reference linked in the description. We keep our own engines running. We spend $2 on a washer before we spend $8,000 on a rebuild. The guys at the fleet lines and the farm shops knew this for 50 years. Now you do too. If you have done this fix, if you have used a washer shim to stop knock on a specific engine, put the engine and the result in the comments. If your truck is knocking right now and you are not sure which type you have, describe what you hear and when you hear it. We will help you figure it out.